So let's take another look at vertical asymptotes, but more specifically looking at the limit at a vertical asymptote and depending on which direction we approach, whether that approach is positive or negative infinity. So let me start off with an example. So let's say we had the function x plus 1 divided by x minus 3. I'll get rid of these parentheses just to make it look prettier. So here's the function x plus 1 divided by x minus 3. So notice a few different things. First thing I see is that there appears to be a vertical asymptote. And if I kind of zoom out a little bit, I know that each of these tick marks is worth 1. So it looks like it's at 3. It looks to me like it's at x equals 3. So from what we learned in the previous video, that shouldn't be too much of a surprise because notice that our denominator is x minus 3, so that means we have division by 0 when x is 3. But I'd like us to investigate that division by 0 a little bit more, involving limits. That is, what happens as we get closer and closer and closer to 3. So I'm going to insert a table, and we're going to look at f of x1, which is what our function is defined here. So let's take a look as we get closer and closer to 3. Now let's go ahead and start maybe from the left side. Actually, I'm going to do the right side first. Sorry, I changed my mind. So let's start with 3.1. Actually, notice when I typed 3, it said undefined. 3.1, so the output at 3.1, so 3.1 would be just to the right here of 3. Let me zoom in a little so I actually get a 3. There we go. So just to the right, like this, for example, would be 3.2. So 3.1 would be right here. Okay, so the y value is negative 41. All right, let's get closer. 3.01, 3.001, 3.001. Okay, so notice that what's happening is that I'm adding more and more zeros. Our outputs are just getting larger and larger and larger. Okay, so what we would say then is that the limit as x approaches 3, as x approaches 3 from the right, f of x grows without bound, so approaches infinity. Okay, and then similarly, if we want to do another table here, and let's go ahead and take a look at this function, but we'll take a look from, these are x2s. Okay, we'll take a look, f of x2. There we go. So we'll take a look now from the left side. Now notice also though, if I approach from the right, I can visually see that as I approach 3 from the right, the y values approach positive infinity. So I can see that graphically as well. So that confirms graphically and numerically. And pretty soon I'm going to show you how we would be able to evaluate that limit without having to have a table of values or without having to have a graph. Let's take a look at the left-sided limit first though. So I'd have 2.9, 2.99, 2.999, and I'm just going to go out as many as I did before. And yeah, that's how many I did before with the to the right side. So notice from the left, what happens is as, I'm not sure why these are all in here. There we go. So now I'm seeing that as x approaches 3 from the left, f of x decreases without bound. That is, it goes in the negative direction, so approaches negative infinity. Okay, so then notation-wise, here's the way that I would end up writing that. So again, we had the function x plus 1 over x minus 3. So numerically and graphically, I saw that the limit as x approaches 3 from the right, plus, was positive infinity. And the limit as x approached 3 from the left appeared to be negative infinity. So what I'd like us to investigate is how could we find these versions of infinity, right, without using a table of values or without using a graph. We talked about in the last video that if I evaluate this limit, then I basically get 4 divided by 0, like if I think about plugging 3 in, and we talked about how that automatically means the limit does not exist, and that the result will be some version of positive or negative infinity depending on which direction you approach. Okay, so again, I wanted to get into more specifics here. So the idea is then if I'm looking at the limit as x approaches 3 from the right of x plus 1 over x minus 3, I don't really have 4 divided by 0, right? Because what's happening is that this is getting closer and closer to 4. And this, well, let's think about that. Well, this, of course, is getting closer to 0. But I want us to think about the sign of that 0, because it's not actually 0, right? Because I'm not letting x be 3. I'm letting x be close to 3. And I'm looking at what happens from the right side. So if I think about plugging in numbers that are just bigger than 3, for example, 3.1, 3.01, right? 3.1 minus 3, 3.01 minus 3, 3.001 minus 3. These are all positive numbers that are very small. So not only is the denominator getting closer to 0, but it's also positive. And we all know that when we take a positive number, positive being 4, a positive number divided by a positive number, we will get a positive number, which is why those values were tending towards positive infinity. Now, conversely, if I look at 3 from the left in a similar manner, again, this is still getting closer to 4, right? And the denominator is still getting closer to 0. Okay, but if I think about plugging in numbers that are just smaller than 3, then that would be, for example, like 2.9, 2.99, 2.999, right? These are negative numbers because 2.99 blah, blah, blah is smaller than 3. So it would end up being negative. And again, we all know that when I take a positive number divided by a negative number, my result will be a negative, which is why these values will tend towards negative infinity. Okay, so that's the way that we could look at vertical asymptotes maybe a little bit more specifically, like looking at which direction we approach, what do the values end up heading towards. Let's take a look at one more example, the one that we had done in the video. So in the video, we looked at the function x cubed minus x squared minus 12x over 2x squared plus 5x minus 3. And we found a lot of things. We found vertical asymptotes, horizontal asymptotes, and holes, but I'd like us to talk more specifically about the vertical asymptotes and the holes. So our first step was we factored. And let's see, this would be 2x, x, 3, and a 1, and this would have to be a plus and a minus, right? Yeah, 6x minus 1x gives me 5x. Okay, and then this part gives me x minus 4, x plus 3. You probably already have that in your notes. Okay, so that was the factored form of the f of x function. So we talked about how this represented a hole because it would be a removable discontinuity. The limit exists. Okay, we talked about that pretty in detail already in the video, so I'm not going to go there again. But then notice that x equals 1/2 still causes division by 0, and not only that, but if I let x be 1/2, what happens is the numerator is going to be some number that's not 0. So it's going to be some non-zero number divided by 0. So again, that tells me then that x equals 1/2 is a vertical asymptote. But let's explore this a little bit more. Okay, so if I look at the limit as x approaches 1/2 from the right side, let's just start with that, of our function. I'm taking the limit as x approaches 1/2 from the right of. Now, you could use the simplified version where these are canceled, or you can use the non-simplified version. I'm going to use the non-simplified version. Okay, so taking a look at this, we want to think about what's happening to this function as x approaches 1/2 from the right. So notice that x would be close to 1/2, so that would be a positive number. Now, if I think about taking 1/2 minus 4, that would be a negative number. 1/2 plus 3 would be a positive number. And again, 1/2 plus 3 here would be a positive number. Now here's where I have to really think, because I can't just think about plugging 1/2 in here because that results in 0. But I want to think about whether it's this is going to sound weird, a positive 0 or a negative 0. Okay, so it's going to be a positive 0 because if you think about a number just bigger than 1/2, think about so 0.5, right, is 1/2. So think about 0.6. 2 times 0.6 would be 1.2. 1.2 minus 1 is a positive number. So this means that I would be taking a positive times a negative times a positive. That's a negative numerator divided by a positive denominator, which means my result should end up being negative infinity. And we'll confirm this graphically also, but let's go ahead and do from the left side. From the left. Okay, so same function. Okay, so if I think about approaching from the left side now, all of my numerator stuff hasn't changed, right? All of those haven't changed, but what has changed now is the value, or I guess the sign of 2x minus 1, because now if I put in a number smaller than 1/2, for example, 0.4, that would give me 0.8 minus 1, which is a negative number. So now what I have is a negative divided by a negative, and that would result in a positive infinity. Let's go ahead and double check our answer by going into Desmos again. And I'm going to go ahead and hide that graph so that we can graph another one. Okay, so typing in my f of x, actually I should do g of x because I already defined f of x to be something else. So again, it was x cubed minus x squared minus 12x divided by 2x squared plus 5x minus 3. Okay, and I'm going to go ahead and get rid of the parentheses in the top. There we go. Okay, so notice that I do see this vertical asymptote at, here's 1/2 right here. So that looks reasonable to me, that 1/2 would be our vertical. Let me see if I type in x equals 1/2. There we go. That makes it even nicer to see. So now you can really tell that x equals 1/2 is in fact the vertical asymptote. And not only that, but notice that if I approach x equals 1/2 from the left, my y values go to positive infinity. And if I approach from the right, my y values go to negative infinity. Just like I saw when I just kind of thought about the value of the limit symbolically. Okay, so you're going to have some homework questions that involve evaluating limits like this. So evaluating limits like this, for example, or the one that we just did. And so that's the way that you can approach those ones to determine whether the value should be positive or negative infinity.